Good morning, guys. I know it's just before the holiday, and a lot of people are usually decide to take an extended stay. So today is, I think we're going to do the solar system, and I have a very good software. I'm hoping that you guys will have a chance to download. It's 100% free, and I think it's one of the most amazing software you can get your hands on, especially if you are into astronomy. If you are not into astronomy, it's a good software to have, and I believe if you have it, if you download it, you'll become interested in astronomy. Okay, so let me get started with the chapter first. For those who came late and watched the recording, apparently I made a mistake into when the homework was supposed to be due. I made it due on the 23rd, which is part of the break for Thanksgiving. So I really cannot assign things due by then, and I really intended it for after Thanksgiving. So I changed it and I corrected it thanks to one of you guys who mentioned the fact that it was on that day. So now it's due on the 30th, which is immediately after the break. Please, again, take your time, make sure that you do it right. Again, today is, again, chapter 26, and this gets us started with astronomy. So we're going to talk about the solar system, basically, because that's the only system that we know at this point. Okay? There are other probably exoplanets that we have discovered. They're in the thousands right now. I mean, about 4,000 or 5,000 planets that are outside of the solar system that we have. We were able to successfully discover. Okay. The point with those planets, usually they are either super big or they have to be really in the way of the star where they are orbiting. So we really don't have a full account of any other stellar system other than our own. So, and actually we use our solar system to learn, or at least, if you wish, postulate how other stellar systems will behave, because we think that our solar system is not, in a sense, odd, and it's not an extreme solar system. So all of the other stellar systems must be similar to our own solar system. Prior to the 1990s, especially in the early 2000s, basically, we didn't know that there were any exoplanets. I mean, the only planets we knew are the planets that revolve around the Earth. Okay, and then we started discovering them, and we discovered them in droves. There was a Kepler project that basically went and looked at small patches in the sky and focused on them, and just by observing how the light from specific stars dims periodically, because as the planet goes in front of it, it basically blocks the light from the star. During those dims, we can determine the planet, how far it is from the star, and so on and so forth. Okay, so that's one technique that we have used. Also, other techniques is to, if we don't see the star, if we don't see the planet, just notice how the star is going around its own, basically that it's moving back and forth. So indicating that it must be near some other object. If we can find that the other object being another star, or if it's basically any other object that is odd, it must be, especially because of how fast it's going back and forth, we can determine, or how far it's going back and forth, we can determine also that it's actually a planet and nothing else. So that's another technique that we have used. We learned so much, basically, and we discovered planets outside of our solar system in the thousands nowadays. So the only thing that we have a full understanding of, or at least a lot of understanding, I cannot really say full understanding, is our own solar system. As a matter of fact, in our own solar system, the only planets that we know for sure that we have visited, actually, in addition to, of course, planet Earth that we have extensively studied, and it's still, there are a lot of things that we need to learn about it, is planet Mars, in terms of planets. Of course, the moon also. That's another thing that we had said lander to it too, a lot, okay? And actually, man was able to land on the moon. So that's another object that we have been able to physically go and visit and touch. Planet Mars, we did not send any manned mission yet, but it's hopefully in the future. But we sent a lot of probes that orbited it, that landed on it, that basically drilled in it. So we have a good idea of what Mars looks like. Venus, we sent a lander, the Russians did actually, But that mission did not last so long because Venus turned out to be super hot, basically object that melts anything that lands on it. So that's the other planet that we were able to. So those are the so-called inner planets. In terms of the outer objects, is stuff that is outside of our own inner planets, namely Mercury, Venus, Earth, and Mars. The only object we were able to land on, or at least send a probe to land on it, was actually a moon of Saturn, okay, Titan. We smashed an object into Saturn, but that object really it cannot survive that much tremendous, basically, pressures and things like that. So again, Huygens was part of a mission of Cassini that landed on Titan itself. So that's the only object that we were able to land. And even the mission there did not stay too long. I think like about 90 minutes or so. When the Huygens, the lander, stayed and took pictures, nice pictures of the moon Titan. Okay, so that's all we know. Basically, we sent orbiters around those outer planets, and we sent basically flybys. As they go by, they take pictures and things like that, all the way to Pluto. So we know a lot about our own solar system. Of course, we use terrestrial observations also and things like that to learn about these objects too. So we didn't have to go there. We have a lot of observation from the ground and from the Earth itself. So that's basically in a nutshell what we know about the solar system. Okay, so let's get the chapter going first. And I will be sharing with you the software. From the get-go, I'll tell you what the software is. That is 100% free. It's called Stellarium. If you have ever visited a planetarium and you saw how amazing it is, and it is, okay, because it brings the entire sky to you, the whole dome basically that is sitting on top of us, and you will see objects in it. That is, and it gives you also actually a voyage, yes, in time. You can go back and forth in time to see basically how the sky would look like an hour, 2 hours, 5 hours, 5 days, a week from today if you want to, and back in time also. The same thing can be done with Stellarium. As a matter of fact, I believe Stellarium is even better than Planetarium because it can give you also all kinds of simulations. That is one thing. The other thing also, and this is item number 1 for the discussion, is this week that we're in right now. It's not really the rarest week in the year, but it's one of the rare ones in the year because you can see all of the planets in the sky, whether in the evening or in the morning, all of them. Okay, you can see Venus and Mercury early in the morning, and you can see the rest of them, especially in the evening, Saturn and Jupiter. Uranus, and also Uranus you cannot see it even with a good telescope, 5-inch telescope. It's very hard to find, but it's there. Okay, you can see it too. Mars is big, visible in this in the night sky. Spends most of the night in the sky, so Mars is visible also. Neptune is even harder to see by eye, but also it's visible during the night also if you have a very powerful enough telescope. So this week, all of the basically 7 planets, of course, Earth is not, you're on it, so you can't see it. So all of the other 7 objects, you can see them whether early in the morning or early in the evening. I mean, after the evening. I mean, like Saturn and Jupiter, you can see them. And if you look at the sky tonight, you see the moon. It's not a, it's a crescent moon. Next to it, there are super bright stars, 2 of them. Okay, those are actually Saturn and Jupiter. Okay. After a while, if you wait an hour, 2 hours later, you will see them go down, and the moon stays in the sky. The moon is not gonna set after. It's going to set after they do. Okay, and that's when the other object and Mars will appear later on in the evening in the east side of the night, basically. So when you're looking at it tonight, and I think it's going to be clear night, it's beautiful for that. look toward the west, where the moon is. Actually, look next to the moon. You will see the other. You are not going to miss them with your own eyes. If you have a telescope, even a 5-inch telescope, you can see them. You can see actually the rings of Saturn. You can see the moons of Jupiter. You can see all kinds of wonderful things. So this is a beautiful night to go out and hunt for these things. If you wake up early enough, around 5 o'clock in the morning, you're going to see Saturn and Venus and Mercury. Venus is going to come out first, and then Mercury is going to follow it in the sky. But if you wait until 6:30 in the morning or a little later, they will start to fade away because of the fact that the sun will come out, okay, and basically block them from you. You cannot see them anymore. It's really exciting things. The other two objects, namely Neptune and Uranus, you're not going to be able to see them tonight. So, I mean, not because they are not there, they are there. It's really, we are on a very fortunate time of the year where all of the other objects on the other side, basically, of the Earth in terms of the night, okay, in terms of how the Earth is spinning, okay? So this is really a very nice time to look at them so they can see them at night sometime, okay? Isn't this exciting? Anybody's interested in astronomy? If you are not, I suggest strongly that you download the software, or at least explore it and see what's going on. We're going to show it today. I'm going to show you the version that I have right now. There is another software if you can get your hands on also. It's a little bit, I mean, it costs money. It's not free. I think for students it's like $21. For the general public, it's like $30. And that software is called Sandbox, Universe Sandbox 2, okay? That actually requires a little bit of hardware. You really need to have a very powerful video card to run it. This one, you don't need anything. You just can go and get it. So, what is my notes in here? Find them. So again, this is about the solar system and how it was formed, okay? And we're going to explore the nebular theory, that it was a nebula in here before. There was a supernova that happened in here, at least one. There were probably several of them in the region that left debris in the sky, basically the leftover from that collision. They spread along several light years, okay? And with time, because of the gravity, the material starts to coalesce, attract one another, okay? And then the more accumulates, the more is going to attract. Now you have a big cloud basically that forms in the area, and the process accelerates because of the gravity. Now, when two objects from far away, they come closer and closer to one another, they lose, of course, potential energy. When they lose potential energy because you have this much separation between them, they gain kinetic energy. So they move faster, in other words, okay? The process is an internal process. There must be conservation of angular momentum, which means that the disk, I mean, the whole mass starts to flatten into a disk, okay? And when there is more concentration of this material, there will be, of course, more attraction. And that's exactly what happened in the core, in the center of this, where a lot of material was coalescing, and that's where the sun was formed, okay? Jupiter started immediately after the sun forming and started to grab more and more stuff. And the sun, of course, starts to form. And then later on in the process, other planets start to form, including the Earth and all of the other objects. The reason why we know this Jupiter was a second because of its huge size. As a matter of fact, if the sun did not go did not go nuclear, okay, and basically expel the rest of the material, Jupiter could have gone into a star too. Jupiter actually is considered a failed star because it did not reach the level where nuclear reactions will happen in it and basically start to emit light. So right now, Jupiter is the second object, then followed by Saturn and all the other big objects, basically, because they grab more stuff in them. So that's basically the nebular theory. That's how the solar system formed. The reason why this theory works is because we can prove it in terms of basically all of the planets are orbiting more or less in the same direction. They're spinning in the same direction. Indication of conservation of angular momentum. Any oddity to that is due to later collisions that happen between the planets basically, and the other objects, and even between the planets themselves. So that's basically what one of them, for example, the tilt of the Earth is tilted, is not spinning exactly on the plane itself where it's supposed to be orbiting. It's actually tilted at 23.5 degrees. And the reason why that is because we think that the Earth actually was subject to a big collision with a big planet, a Mars-sized object that hit it. And that Mars-sized object that hit it basically exploded and tilted the Earth a little bit. And then that object, the debris that was left over of it, basically formed the moon later on. So, because the Earth has a moon, which is really an odd thing. It has a big moon. Unlike Venus, for example, that does not have one, or Mars, it has two tiny moons that are captured, actually, asteroids. So this is really how we think that the theory works. And actually, if you look at Uranus is actually tilted completely upside down. I mean, it's not spinning on the plane, it's spinning 90 degree on it. I'm sorry, it's, yeah, almost 90 degree on it. It's actually more than 90 degree on it. So basically, we think that also that would happen to Saturn too. So that's basically what, in a nutshell, the theory works, and it's a beautiful theory. We're going to talk about the sun, because that's the only star that we know nearby, okay? The inner planets, there are 4 of them. From their proximity to the sun, you have, of course, Mercury, followed by Venus, followed by Earth, followed by Mars, okay? They are rocky objects because they are too close from the sun. And so basically whatever gases they have, they most of the time basically lost it, so the rocks themselves left. This is after the sun basically went nuclear. And what happened with the Earth and, for example, the Venus, they have an outgassing process. They have volcanoes, okay? So they produce all their own gases, and they retain them because they have tremendous gravity. Versus, for example, Mars, that did the same thing early on, but it did not have a lot of gravity. It's smaller than the Earth and Venus, so it lost most of its gas. Basically, the same thing is also with Mercury. So those are your 4 inner planets. Then there is actually a line between Mars and Jupiter, which is called the first line, below, after which the temperature is so low that the water becomes solid, becomes ice. So that's where the giants reside. That's where Jupiter is. That's the big planet. It's 11 times in diameter bigger than the Earth. It's much, much bigger than, as a matter of fact, it's the biggest planet in the solar system. Okay, then it has, then after that comes Saturn. Saturn is actually smaller, and it has rings. As a matter of fact, we thought initially that only Saturn has rings. It turns out that all of the outer planets do. They are very thin, and you cannot see them even with the small telescopes. But with the further studies, we saw that even Jupiter has rings. Uranus has rings too, and Neptune also has rings. So those are your 4 outer planets. Pluto, initially there was a big fuss over it, and we thought that it's much bigger than what it was. It turns out to be a lot smaller than what initially was reported, and it was believed to be the 9th planet up until we discovered other similar basically objects similar to it, and it was demoted to basically because Eris was discovered, other Sedona and Makemake and other objects that are in the same area in the Kuiper Belt, basically, that also have similar properties to Pluto. So if we're going to keep Pluto as a planet, we have to also promote the others into a planet, and then we have basically a large number of objects. And they actually, not only that, there is actually a new definition of a planet that Pluto fails at it. In 2006, it was demoted back to a dwarf planet. So it's still a planet, but not as big basically as the other 8 planets. Of course, we have other debris in the solar system that is basically left over. We have 2 main types. We have asteroids, which are rocky objects, and they mainly reside between Mars and Jupiter in the so-called asteroid belt. And then you have comets. Comets are actually icy objects that are, once they are about 5 times the distance between the Earth and the Sun, they're actually solid ice. Once they get closer, they start to heat up, and their eyes basically starts to melt, and they form a tail. So as they go around the sun, they form their tail, and then once they move away, they are actually back to their solid form. Their orbits are very elliptical orbits. So that is really mainly the structure of the solar system in terms of their objects. Now, there are, in addition to, you have the so-called inner planets. There are 4 of them. Then you have the asteroid belt that is between the Mars and Jupiter. And then you have the Kuiper belt that has a lot of this stuff, including Pluto and all of the other smaller objects in it. This is the extent of the solar system to some extent. Then there is another object that comes. Those are all mainly on the planar, basically, of the Earth where they're residing. That's the most extent, if you wish, of the formation of the solar system. But then there is far more objects that extend several lengths away, and that is the Oort cloud. The Oort cloud are actually spherical, so they are not impacted by this flattening of the entire solar system. So the Oort cloud right now extends very far away, and the magnetic field of the sun does not extend all the way to the end of the Oort cloud, but the effects of the sun extend all the way to the other ends, meaning that the sun has an effect all the way to probably about 2 light years away from here, which is very, very far away. So it's almost to the half the distance to the nearest star. So this is basically, in a nutshell, what the solar system is. So again, the outer planets. We talk about the moon because we have had a chance to actually send people to it, and people went there physically and grabbed materials from it. Turns out that the stuff that the moon is made up of is not far from the Earth. That's why we think at some point there was a collision in the history of the Earth that formed the moon, because a lot of the materials that are on the moon, they are similar in composition to those of the Earth. So that was some of the things. Buzz Aldrin and other people went there, and I have had a personal chance to actually attend one of his presentations in St. Louis. So the room was full packed. I really did not have any questions. What I wanted to do is just see him in person. That's all. So that is something about the moon that we're going to talk about. And then, of course, I mentioned the asteroids and also the comets. Those are the so-called failed planets because they did not have a chance at all to even be promoted to a dwarf planet. So they are very tiny objects, and their motion is a little bit different. Okay. So this is in a nutshell the chapter. So this is the divisions of the planets. You have the inner planets. No, Pluto is actually a dwarf planet, not a failed planet. Okay, Pluto is a dwarf planet. As a matter of fact, Pluto itself has a big moon. Charon itself is a huge moon. Relatively speaking, it's the biggest ratio of moon to planet. Of course, the next one is actually Earth, also with its own moon, which is big, but it's not as big as that ratio. But it has actually other moons too. So it's not just this moon. So it's a dwarf planet with several moons around it. At least we counted 5 of them so far. So it's not like, for example, a comet. Comets, for example, they have their orbits that are very, very elliptical. So they come around the sun, very close from the sun, less than in AU, less than the distance between the Earth and the sun, and they go very far. Like, for example, Hades comet. That is actually a failed planet. But and also the asteroids, that are so many of them, for example, scattered between Mars and Jupiter, and some of them are actually sitting on the orbit of Jupiter in very specific locations, and some of them are scattered in the entire solar system. And from time to time, they become meteorites when they hit the Earth, and they hit also planets, also like Jupiter, which is a big basket that collects a lot of these things. Okay. I mean, we're blessed in a sense to have Jupiter in there. Otherwise, probably life would never have had a chance to evolve on Earth because of this failed planets that are so many of them in the solar system. But because Jupiter is huge in size, so it acts as a shield, basically protecting all of the inner planets, especially the Earth, because that's where life is right now. Okay, so we'll get into some of the things. Let me first of all fire the software that I told you, and I'm hoping that you guys will have a chance to download it. And I want your feedback on it. And if you have had a chance to do it, if you can do it, that's fine. If you wanted to do it later, that's fine. But that's the item 1 of the discussion, okay? Stellarium. Stellarium, as opposed to a planetarium. Okay, so this thing, when it goes into a full mode. So let me see how I can do it so that it doesn't. How can I do it in such a way that I don't have oh man, yeah, here it is. Okay, good. So let me share with you the screen. Is everybody looking at this software? At least one person in confirmation, verbal confirmation, because I can't.
Yep.
Okay.
Yes.
So this is the version I have. Okay. This is the latest version, actually 0.3, okay, which is the latest download. When I downloaded it today, it was telling me that it needs updates. The location right now, it's in Loma Linda, because that's how it detected my location, okay? You can go into your own software and change your location. Where is it? Is it in here? Okay, yeah. You click in here, and you can put your own location if it is not there. I mean, as a matter of fact, you can simulate other locations. You can say, for example, I want to be on Mars, for example, on this, what is that lake that we're going to send the Perseverance in it? Jezero Lake, okay? So you could be there on that lake. On February 18th, 2021, around 12:30, the lander, Perseverance, will land on Mars. And it's going to land on this Jezero lake on Mars. So you could simulate your location there, okay? And see the night, how it looks like from that perspective. But of course, you can do it on Earth, especially if you're traveling and you have your telescope with you, and you would want to know what can you see, what you cannot see, which direction, and which all of that. So you can actually put that location in there, okay? And it's going to give you that. So right now, it's set to Loma Linda, United States, and this is the geo coordinates for it. And actually, it picks up the time from your computer. And right now, it's almost 9 o'clock. So this is how the night sky would look like. This is where the sun. And of course, we can see any other objects. It's pointing towards the south. So if I'm looking to the south, the landscape in here is just a landscape. So you can remove the landscape if you like, but it's a good area to keep it. Excuse me. I'm sorry, this is the night sky. What is the landscape? Here is the landscape, okay? So you can remove the landscape, but it's a good idea to keep it to give you a visual where the horizon is, okay? But this is what I like about it. You can change the location, and you can also change the time. So for example, oops, let's keep south. Let's keep looking. Let's keep southwest, okay? Because I want to see exactly what I can see at night, okay? So if you drag this, you're going to see the different times. So if I'm going to go, I can click the time and make it look like I'm at 5 o'clock in the evening. This uses military time, by the way. 5 o'clock is 17, okay? So 5:59 this evening, looking at the southwest, you will see the moon in here. Let's go an hour before. Let's go at 4 o'clock, okay? 4 o'clock, the sun is still in the sky, so probably you're not going to see 4:59, that is. It's almost 5 o'clock, okay? Okay, 4:50. So this is, you're going to see a dot in the sky next to the moon, but if you can't, you wait another hour, okay? This is 5:50. This is almost 6 p.m. 6 p.m., what you see in the sky is Jupiter and Saturn, as I was saying. The brighter one of the two is actually Jupiter, okay? And the lesser of the two is actually Saturn, okay? And then you have the moon next to them. So those are the two big planets. The data that you're looking at in here, okay? This gives you a lot of the information in here, including this value in here that I need you to pay attention to. The negative 9.4, it's a very small number, of course. When it's the smaller it is, the brighter it is, okay? So that is the absolute magnitude. This is the magnitude and how much you see it. Okay, those two numbers are important because it tells you how bright the object is. And also, it gives you the location in the sky, okay? Those are the right ascension and the altitude or the azimuth, and this is basically the angles that you can measure for. You can find it in the sky. Again, they're visible at night. All you have to do is just look in this direction, south, southwest, between these two, and you're going to see the objects in here. Look at Mars. It's in here. It's south, southeast, and it's also an orangey object, and it has also high brightness. I mean, it's not as bright as the other two, but it is big enough. I mean, negative 1.5 is still a big number. Okay, so it's bright and orangey object, and you can see it in the sky. Okay, you can download the software on your phone, but it costs money. It's $3. I think that's how much they charge for it. But on the computer, it's 100% free. I have both of them. I like the one on the computer. It gives far more information than the one on the phone. It's really very, just to give you an object. Here is where Uranus is. Okay. Uranus, now the number in here is super high. I mean, its intrinsic brightness is super bright, but you cannot see it with your eye. Okay. This is how far you can see the telescope, and I'm not going to, you can simulate the telescope with these things. You can see it better, but it's, again, let me zoom on it and go closer and closer, and now you can see how the planet would look like. So this is Uranus. Now from this point, you're going to see some of its moons. Okay, what is this object in here? It's actually a star. So these are the moons: Oberon, Titania, Umbriel, and of course you have Uranus, and more moons starts to become visible as Miranda is a big famous moon of Uranus. So this is basically how it looks like, and now you can see even the rings on it and far more moons on it. So as you can zoom closer and closer, it's really an amazing software to have, because short of actually doing it by yourself, it's, and now the moons and the rings are actually going to be moving in here as you get closer and closer to it. So this is super nice. Okay. Let me go back out. So let me go into the, okay. So this is how it looks like right now. Okay. When you are zoomed out, doesn't look much, does it? And that's it. Those are the two around 5:54, just before 6 p.m. I'm sorry. Okay. Now, if you wait a little longer, you ask, where is Neptune? I don't see it in here. Okay. So you can search for an object. Search. Okay. I last did search for Neptune, and actually here it is. Okay. You cannot even see it. Okay. It's in the sky too. But again, you have to use super powerful. As a matter of fact, Neptune was discovered by mathematics. It was not discovered by observation, because it's super far. You cannot really see it. So, and here it's moon, what is it, Triton? It's a big moon also. So now you are very close from it again. Okay, those are super far objects. But again, this is 6 p.m. and you're looking at basically 5 of the main moons, 5 of the main planets of the solar system. Okay, Saturn, Jupiter, Neptune, and Uranus on the other side, and Mars. Okay, so the only 2 things that are missing right now are Venus and Mercury. So if you wait in the morning, so I'm gonna fast track this one to now I can turn on something else, which is very nice also. I'm gonna turn on the constellation names and also the constellations themselves. Aldebaran is part of the Taurus, okay? And then this is the arm, and actually of Orion. We already see part of Orion around 7 p.m., okay? If I wait a little longer, go to almost 8 p.m., now you see Betelgeuse, you see Rigel, and you see the entire constellation of Orion basically rising. And if you go a little later at night, you see the entire constellation, including Safe, including Nitaq, and also, what is it, Nilam, and Mintaqa, which are the 3 stars in the belt of Orion. If you guys have seen the movie, what is it, Men in Black, they talk about the belt of Orion. The belt of Orion apparently turns out to be a cat's name than the belt where the constellation was. or not the constellation, where the galaxy was in the movie at least, but they were looking at the belt itself, and those are the three stars in the belt. As a matter of fact, if you zoom closer on the stars, there are not only three, there are a lot of stars in the belt itself. But that's basically the constellation itself. So if you go a little bit in time, more constellation actually Ceres in here, and Canis Major, which is the dog of Orion, starts to appear. Ceres is the brightest star in the sky, so it's really a nice thing to explore also. Okay, Ceres is actually a binary star system. It's two stars in one. So this is 10 p.m. or 11 p.m. I should say, and the other two planets did not appear, so they have to appear in the morning. Actually, this is midnight now, 1 a.m. We have to wait until later at night. Now, this is what, 6 a.m. So let me go back in time in here and fix this one in the morning. So 5 o'clock in the morning, Venus is already appearing in the sky, 5 a.m. So again, tomorrow morning, look between the east and the southeast. This is the east, and this is the southeast. Okay, so look in there, just above the horizon, where Venus is going to appear. If I wait another half an hour, and now I cannot really move into it. Mercury also appears just above the horizon. Venus is going to be a super bright object. As a matter of fact, it's one of the brightest objects that you're going to see in the sky. Okay, the morning star it's called, and it's 5:30 in the morning, and you're going to see it. That's how they used to call it. They sometimes call it the evening star, sometimes the morning star, because it's always seen either early in the morning or late in the evening. You cannot see it because of the fact that it actually follows the sun. Same thing with Mercury, by the way. Mercury, and if you wait another 20 minutes later, so it's 5:50 in the morning, the sun starts to come and starts to block your view. Okay, so around 6, let me go back, 6 a.m. the sun actually starts to make this object fade. Maybe you'll be lucky if you can see Mercury anymore, but the other objects in the sky, they already have gone a long time ago. Maybe what's his name, where is it? It's gone also. I was looking for Mars. Okay, if you wait another half an hour, you cannot probably see much. Okay, everything is gone in the sky because of the fact that the sun now is there. This is 7:30 in the morning. So this is really a lucky thing to have, because we are really in the time of the week, basically, where you can see all of the other objects in the solar system. Of course, a few of them, a couple of them, you cannot see them with your naked eye, and even you need a powerful telescope to see them, but they should be visible in the sky. So those are the all of the objects in the solar system in terms of the big planets, all of them, all of the 8 of them. At least, of course, we're counting the Earth as the 8th one, so the 7 of them, okay, that you can see with your own eyes. So let's continue with this thing in here. So those are the 8 planets, okay. The nebular theory, I talked about it, the fact that how basically a supernova happened. So the sun formed not from the first generation of the stars that formed immediately after the universe had formed. So it's not first generation star. So there must have been first generation, probably second and third generation stars that have formed after the Big Bang in the region where we are, and that's where the sun is formed. The reason why we know that for sure is because we have iron on Earth. In all of the solar system, we have iron. Iron cannot be formed except through a supernova process. So that's really the thing with iron. Cannot, and heavy metals cannot be formed. The sun cannot do that on its own. The sun is basically a small star, relatively speaking. Okay. So again, I explained the process of how the material starts to get together, and as if you're working your dough, basically it's going to start to move faster and faster. Yeah, the first question was to explore Stellarium software, and tell me, were you able to download it, how successful it is, if is it good, did you have a chance to download it? If you cannot, please let me know that also you cannot, and what your plans as far as this software is. What do you think you can do about it? Okay, you need to type it. I guess I forgot to type. That's a good question. Okay, the question is, I think I put just the what, your input, your reaction. How to use Stellarium. Okay, that's all. Okay, so it's a general question, really. Okay, good. Okay, so again, the planetary for how planets form, at least that's the theory that we have, and it seems like it's confirmed with other observation of other actually nebula out there, that this is the process through which stars are formed. And as the debris basically gets closer and closer because of the gravity, it's going to gain more and more velocity because of the loss of the potential energy to kinetic energy, and then because the conservation of angular momentum in this case forces the flattening of the disk, and the object, of course, to move faster and faster. As a matter of fact, the conservation of angular momentum explains the first law of Kepler and the second law of Kepler. Both of them are explained just with the conservation of angular momentum. Okay. I'm sorry, the second and the third. The second law, at least, of Kepler. The first law has to do with the orbits. Okay. Obviously, astronomy is a big topic, and just the solar system can be a class by itself. I know in RCC they teach physics, astronomy 1A and astronomy 1B. One of them, 1A, is specifically for the solar system. So you could spend an entire semester just talking about this stuff and exploring it. Okay. So the sun is the nearest star to the Earth. That's what we know right now. Composed mostly of hydrogen in the plasma phase, meaning that it has protons. That's what the plasma phase is, as far as the hydrogen is concerned. Hydrogen is fused to helium by thermonuclear fusion. Basically, when hydrogen and hydrogen they collide, they're very close from one another. They basically fuse, and actually, you need the process is far more involved because it involves also other materials in here. And once they fuse, they form basically helium, different isotopes of helium. And the process continues into formation of lithium and other basically elements. So the process is very much complicated, not how should I say, involved. And at the end, you will have a release of energy because of the fact that when they fuse, it's less energy than when they were isolated. So hydrogen and hydrogen, once they are ionized, they repel one another. They don't really like to come to one another. But once they reach a close distance, then they can attract one another because of the nuclear reaction, the nuclear force between them. This process is very rare in the sun. So for hydrogen to really fuse with another hydrogen, the probability is very low. However, because of the sheer amount of hydrogen that is inside the sun, it's happening all the time, and we get our energy mainly from it. So, and the sun has been doing this for a long time, for over 5 billion years, and it has another 5 billion years to go before it runs out of fuel, basically. This is happening in its core, okay? And the energy that is basically converted into energy, basically the mass that is converted is very huge amounts. So there are 4.5 million tons of mass every second. From the class it started until now, we have, what is it, 45 minutes already. Count how many seconds that is, 45 times 60, and you will see how much amount of matter basically was converted into energy by this process. Yes, it's a rare process, a rare probability for given a hydrogen atom to go basically and fuse with another hydrogen atom, but we have a lot of them. That's why we have a lot of them that basically are going into this process. Okay. Obviously, the energy is going on a sphere, and it's going everywhere in all directions, and we cover a very tiny portion of that entire sphere. Okay, the Earth. That's how much it's going to get. We receive on average about 1,200 basically kilowatts per square meter. So if you have a square meter right now, you go outside and put it, the amount of energy that falls from the sun is almost 1200, not kilowatts, 1200 watts, okay, of energy per second. Kilowatts are going to be a lot of energy. The mass of the sun decreases, but it's a very, very tiny thing in here, okay? So it was one of the puzzling issues. How come the sun is bright? And people thought initially that maybe it was burning wood or some sort of like things like that. There is a chemical process that could not sustain it for this long. It has to have been a nuclear process, okay? So the mass will decrease because of the relationship E equal to mc squared of Mr. Einstein. Okay, Mercury, okay? Mercury is the closest planet to the sun. It's super hot during daytime and super cold during nighttime because it does not have an atmosphere. That's the problem, okay? And the density of Mercury is super dense. It's actually the second densest object in the solar system after the Earth. The Earth density is of 5.5 grams per cubic centimeter, so it's super dense. Actually, the Earth is the densest object in the solar system, okay? Followed by Mercury itself, which is 5.4 grams per cubic centimeters. Venus, which is the next planet in the solar system, it's almost the size of the Earth. Actually, it's the twin of the Earth. Okay, there was some talk and things like that in the past couple of months. It's really the last month where we discovered what looks like leftover of life activity on its atmosphere. And the atmosphere of Venus is not really bad, but when you go down in it, because of the tremendous pressure from the atmosphere on Venus is about 90 times the atmosphere of the Earth. So if you think that you are underwater and under pressure for about 10 meters, that's going to give you what, 10 atmospheric pressure? That's not enough pressure. You have to go super deep in the oceans to feel that pressure. It's going to crush anything, just the pressure alone. And then you have the heat, okay? And then you have the acid that is raining from the sun. So it's really very, very, very bad place to be in. It has a lot of volcanoes. It has a lot of gases. And at some point in the past, not too long ago, about 150 million years to probably another 550 million years in between that period, it was really an Earth-like planet. It had oceans, had water, it had land, it had everything like the Earth is right now. And Venus had those conditions. For some reason, right now they're being explored, that probably it was hit by some sort of asteroids or something like that, that triggered volcanoes, and those volcanoes started basically emitting CO2, carbon dioxide, which made its atmosphere basically, which trapped heat, and whatever water was in there evaporated, and because of the tremendous heat, those H2O basically was dissociated, was broken into hydrogen and oxygen, and the hydrogen escaped, of course, and now it's devoid of water for the most part, okay? So it's really a greenhouse effect that started at least about 150 million years ago, and that greenhouse effect made this planet basically rendered it lifeless, impossible for any life to exist in it, at least the one that we know of. Right now, there's speculation that maybe life exists in its atmosphere, somehow survived in its atmosphere. But that's basically what it is. So if we're not careful enough with the Earth could undergo the same thing. There is no real reason why it could not go and become another Venus. As a matter of fact, it has more mass, so the potential for it to go in a Venus-like is probably actually a little higher because of that. So we have to be very careful. So this greenhouse stuff in here, we have to really be careful with it because it could go under, you cannot control it anymore. And if it's the case, then hey, you're basically, you're out of luck. There is no other room for us in the planet, so in the solar system at all. Venus is not, at least, okay? Mercury is completely out of the question because look at the temperatures. And it has no atmosphere, so forget it, okay? Mars has a very tiny atmosphere, okay? Every stellar system has a place in it, around it, where water exists in a liquid form. In the sun, it's basically from where almost Venus is to where Mars is. So those planets are actually suitable for the water to be in a liquid form. And this is the so-called habitable zone. This is where we think life, at least in the one we know of, exists. So this is basically Earth happened to be right in the also in the middle of that zone. So this is where water can exist actually in all three forms: liquid, solid, and gas. So this is where the conditions for life also probably exist. So this is the so-called habitable zone. Anything outside is too cold for water to exist in a liquid form, so it's going to be solid. Anything below, water cannot exist in a liquid form or solid form for that matter. It's going to evaporate. And because of the lack of gravity on Mercury, it's going to completely escape. It's gone. Okay. So Mars has a very, very thin atmosphere. As a matter of fact, the pressure on Mars is very, very low, and it's really not sustainable. At some point in its past, it had life, probably. I mean, I don't know about life, I'm sorry. It's had the liquid water, it had running water. We were able to find all kinds of evidence for that. And its temperature ranges for a few days, not too long, okay? Between 30 degrees and negative 130 degrees, okay? So most of the time super cold, sometimes it gets to comfortable temperature. Actually, it's a little warmer than what it is today here, okay? So it's being explored extensively, but I think it's really false hopes as far as I'm concerned, because it lacks atmosphere, it lacks a magnetic field, it cannot protect life because of this extreme conditions that it has on itself. But we spent a lot of, basically sent a lot of resources in there, and we're continuing, and I think Elon Musk is working very hard to have probably manned mission them there. Not only him, a lot of people out there actually thinking about that. So I'm excited actually for February 18th at 12:30 our time, California time. And I'm hoping to basically get maybe some people from the campus to at least do some sort of an event on that day where we can, it's going to be a Thursday, where we can actually follow the lander and make sure that it can safely and hopefully deploys all of the other things, and thumbs up for it. Okay. There are actually 3 missions right now ongoing to Mars. There, one of them by the Chinese. The Chinese, they have an orbiter actually going to orbit Mars. The reason why they send them in July is because this is the time when we are. This is actually a very good time to send stuff. It was actually in July, because this is the closest points that you're going to cost you the least in terms of energy and so on and so forth to get there. So there are 3 missions. One from the United States, Perseverance, which is a lander. And actually, it will have also a hovering system, like do you call them those things? Not yeah, like a helicopter, but the ones that you get them from Amazon, they fly. I forgot the name right now. Anyway, it will have, and it will also probe into the surface, and it has several cameras and actually also spectrometers to measure the all kinds of things. So this is an exciting mission by itself. The Chinese, as I said, they will have an orbiter, but they said that they're going to send a lander also. They're going to send the probes to the planet. The UAE, United Arab Emirates, also they have a mission going in there, and that mission will only be basically mapping the entire planet. Okay, so that's the mission that is that's going to collect a lot of scientific data basically to examine the planet. So those are the 3 missions that are going to happen around by the end of January, early February. That's going to, they start to basically working in there. Okay. Anyone is excited about February 18th? That's the second topic of the question. What do you plan? What is your plan for February 18th? I'm fine if you tell me that I'm done with this class and I don't need to think about it anymore, but I'm hoping, and I'm hoping really seriously, that you will consider following what's going on in terms of the landers, or at least the missions to Mars, all 3 of them. So that's the second topic of the day. Okay, I'm hoping that you guys do it, but if you tell me, hey, listen, I'm done with this class, I'll be happy to basically go in my own business and work, that's fine. Okay, I'm not going to hold any grudge about for that or do anything that's okay. Get the question, guys? Okay. You're not going to attend this thing, then I'm going to make sure that you're not going to pass the class. I'm not going to do that, okay? It has nothing to do with it, okay? So I'm hoping that you're going to be as excited as I am about these things. Okay. Okay, so let's continue. Where are we? We're talking about this Mars, okay? And again, this is some of the missions that happened before, basically, where we actually sent landers. So there are several missions in here, mainly by the Americans. Nobody else. Actually, this is the first time that probably there will be a lander other than the Americans by the Chinese. I mean, their lander, at least the one that I was looking at, the other, I think, was like in July when they announced it, because in order to master how an object lands in there, you really, it's a complicated technology. And so what they are saying in here, they will deploy a parachute, they will also fire engines, and they will also have a bubble like the one that the Americans use to protect their lander. So at this point, it's really an experiment that they are running. Whether or not they will succeed at it, I don't know, honestly, because it really takes a lot of experimentation first, and then also the NASA was not successful from the get-go. So this is basically the first time. So I'm hoping that they would succeed, honestly, because we need the more data we have, the better it's going to be. But I would not be surprised if they don't. Okay. So that's really the thing, that because this is the first time that they're going to do it. So the outer planets, we have Jupiter, Saturn, Uranus, and Neptune. Okay. In terms of discoveries in the old days, basically, we still have time. So in the old days, basically, people with their own eyes, they saw Jupiter, they saw Mars, they saw Venus, they saw Mercury, they saw also Saturn. Okay, those are the 5 objects they saw in the sky. In addition to that, we know of the moon also orbiting the Earth and the sun. People then thought that the 7 objects orbit the Earth until Copernicus challenged the idea and came up with a better explanation that actually all of them orbit the sun, including the Earth is. So the moon, they called the day that follows the moon Monday, the moon day, the day of the moon. Tuesday was called actually for Mars. I don't know if there is a god in the, I forget the theology there, how it's named, but actually in French and actually in Latin languages, it's Mardi, and I think also similar words in Spanish, and that is because of Mars. Okay. Wednesday is, I think there is also a word in Spanish that I don't know very much, so don't ask me to say it, but it's also in French, it's Mercury, which is the day of Mercury, basically. No, Mercury is, yeah, okay. Then comes Jupiter. Jupiter, the day for it is Thursday, okay, jeudi, okay, in French, and I think there is similar word in Spanish. I don't know it. Okay, Latin languages, they line up better because the American, the Anglo-Saxons, they use different names for them, following the gods in Germanic culture. Okay. Then Vendredi, which is the day of Venus, which is Friday. So you have 5 days. Then Saturn, which is the day of Saturday, which is the day of Saturn. Then the day of the sun, Sunday. So those are the 7 days following the 7 objects that we see in the sky. It was later on discovered by accident. Actually, there was another planet, Uranus. Okay. So technically, if Uranus have been discovered by then, we could have potentially had 8 days in the week instead of 7. Right now, the only reason we have 7 is because there was 5 objects. Okay. Yes. Okay. So there was Uranus that was discovered, and then Pluto was discovered by mathematics, because 2 astronomers, one from France and another one in England, they made calculations and they said, if you look in this specific point in the sky, following basically Newton's laws of motion and also Kepler's laws, if you look at this specific point in the sky, you will find an object in there that has this mass, and it's a planet actually. So Neptune was discovered by mathematics. So again, if Neptune was known then, imagine how many days of the week there could be. We could be working 9 days of the week, okay? But for some reason, we didn't know about the other two, Uranus and Neptune, so we were done with only 7 days of the week, okay? So astronomy influenced culture a lot, influenced also actually agriculture, influenced so many things, okay? Until today, it continues to do so. So it influences also science, the evolution of almost all of the other branches of science. The telescope actually was a toy until Galileo took it and actually pointed into the sky and saw, among other things, the moons of Jupiter. Okay, so this is Jupiter, is a gas planet. Okay, and it's really the biggest planet in the solar system, as I was saying. It's much larger than the Earth, and any other object. Okay, it's 82% hydrogen, and the next one is helium. This is why we think this is actually a similar composition to the stars. Actually, okay, it has methane and ammonia, and that's what gives it its color. Actually, those other gases, including a little bit of water vapor and things like that, that's what gives it its white color. Okay, and all of these things are due to methane and all of that. The big feature of Jupiter is this swirling, basically. Hurricane, basically, like atmospheric, basically disturbance that's been going on for hundreds of years. Okay, it's changing shape though, and it's decreasing in size. Earth would fit in a lot of very tiny region in here, so this is a supermassive object in here. Okay, and it's really, it may have a solid core, but we can't really know for sure, honestly, but that's probably how it has formed also. It's actually collecting stuff like that, but it's super dense inside. It has actually liquid hydrogen to the point that hydrogen becomes liquid. So this is liquid hydrogen, which is a metal, and that's what gives it super powerful magnetic field because of that, because hydrogen is a metal in these conditions. Okay, so the 4 moons of Jupiter was seen by the toy that Galileo has discovered, and that refuted a lot of the points that everything revolves around the Earth, because here are 4 objects that Galileo had seen, and they don't revolve around the Earth; they revolve actually around Jupiter. Our moon is a little bit the size of Io. This is the nearest moon, the closest moon to Jupiter. And in terms of size, you have Ganymede, you have Callisto, and then you have Io, and then you have Europa. Europa itself is an interesting object, because if life exists in the solar system other than the Earth, most likely it exists in the oceans underneath Europa itself. Okay? Because Europa has a very thick icy structure, and underneath of it there is actually salty water, just like our oceans. And it has far more water in it than the entire Earth. Okay, as a matter of fact, it has far more water than a lot of the objects in the solar system. So there is and because of the fact that it's so near the Jupiter, it actually goes through tidal forces. Those tidal forces warm it from inside and probably give energy to whatever life form exists in its oceans. So Europa is actually a good candidate for life, and this is something that we could explore. However, the atmosphere, the layer, I mean, the ice is super thick. And we don't have any technology right now to dig through that ice to go all the way to the ocean. It's super thick. So there is no way that we can know for right now for sure. Okay. But from time to time, there are some ruptures that come in, and that's how we see basically eruptions that are probably going to flow from this moon. Okay. Then Io itself is too close, and it's going to tremendous tidal forces, because it's sometimes it's being pulled by the other 3 moons, and actually Jupiter from one side, and it's really being like needed all the time. So if you look at it, it's the most volcanic object in the solar system. It's worse than Venus, and it's the hellish place on Earth, on the sun, and the solar system, other than Venus, of course. It's really super nasty thing, and it's always oozing of this basically sulfur, compounds, that looks like from distance that it's really ugly thing in there. But it's an interesting object because of its proximity. And it's losing stuff all the time because of its proximity to Jupiter. The other two moons are further away, and because of the active craters that are the active meteorites that fall off them, you have this basically cratering structures that look in them. These are far big objects. They are actually the biggest moons in the solar system, including to them, adding to them Titan from Saturn. They're the biggest objects in the solar system in terms of moons. Okay, but they also have oceans, and they also are potential for life in their inside of their moons. But they're too far away to have substantial basically energy and light that's coming from the needing, for example, for the tidal forces, and like the Europa, which is a really good candidate for life in itself. Okay, life as we know it, carbon-based life, basically, maybe fish and things like that in the oceans and that. Again, this is Europa itself, the one I was talking about. So it's mainly liquid water, but the ice structure in here is super thick in here. Okay. Then comes Saturn. Saturn is an interesting object. Also, it has a lot of rings visible to us. Okay, and the rings, they have a very specific structure in here, and they have moons that chaperone them basically and keep this nice thin, super thin structure for the rings. Saturn actually is the least dense object in the solar system in terms of planets. Okay, as a matter of fact, if you take Saturn and put it on the water is going to float because its density is less than 1 gram per cubic centimeter. Okay. Its moon Titan, as I said before, was the only object that we were able to land on it. This is the surface as it was landing, and it was taking pictures from it. It looks like this color, which is the orangey color, because of the methane that is in the atmosphere, and actually the liquid methane that is actually on the surface there. It looks like it's made up of water, but it's actually methane liquid on its surface. Oceans, I mean not oceans, lakes and things like that on it. These rocks that you see in here are actually ice, water ice. Okay, so that's the surface on it. The lander Huygens stayed there for about 90 minutes before basically it ran out of energy, so it couldn't communicate where its location because super cold the moon is. And it has actually an atmosphere. If you stand on the moon itself, Titan, you wouldn't feel a lot of pressure because of the fact that it is the same atmospheric, almost the same atmospheric pressure of the Earth. This is actually the Earth-like object in terms of its surface, in terms of it, what looks like it has oceans in it or lakes in it. And it's also of the cycle of the weather on it, except that instead of dealing with the water in here, we have methane instead of dealing with the, so this, the phenomenon is a little bit different. And but it's really potential also object to be studied. Cassini later on basically ended its life by going straight into the into Saturn itself. Okay, that happened in 2017, not too long ago. Okay, comes Uranus. Uranus, as I said, is really an upside down planet because it had actually collided at some time in its past with another object that basically tilted it. Okay, it also has ring structures. Okay. And it has a methane and atmosphere, and it's also a very cold place. Neptune has rings actually too, okay, and it's similar because of the bluish color in here. It has also the similar thing, which is the methane structure that it has in its atmosphere. Okay. Nice. Okay, we're going to talk about that next time when we talk about the universe. So Sherry is saying a link for the how big the universe is. Okay. Okay. Again, Pluto. We may mention the fact that it was demoted, and because we found so many objects, one of them is actually slightly bigger than it, or at least almost the same size of it, Eris. And other ones that are similar in size, Maki, what is it? The other one is it Sedona, and so many of them in there that are really Too many to count, okay? You don't need to remember their names. But they are dwarf planets. They are still planets, though. Okay, so you're not too happy about that. It's still a planet, okay? So the reason why it was is because it's still, its neighborhood is not cleared, so that's the new definition of what the planet is. Earth's moon, as I said before, was the only object that we visited in there. We brought materials from it. Until now, they continue to be studied. And we note that the structure is actually similar to that of the Earth, and that's why we thought that it must have been formed during a collision between the Earth and another object. This is Buzz Aldrin himself, and like I said before, I really had a chance to attend one of his speeches, and he was talking about his experience. And that's really, for me, it was a really very nice thing to do. Okay. Again, this is what we think happened to the Earth in its early history. Because the early history, there was a lot of objects in the solar system. Some of them went and collided with the sun. Others collided with other planets. Other probably was kicked out of the solar system. Like, for example, this hypothetical planet line that we think exists because there is some oddity motion in the objects that are in the Kuiper belt themselves. So then maybe there is another planet 9. So there was another planet that was actually similar in size to either Mars, Jupiter, Mars or Jupiter, Mars or Mercury, that hit the Earth at the right angle, and then that forms the debris, and then the debris coalesced later on and basically formed the moon again. Okay, that's why we have similarity in terms of compositions and things like that. The moon goes through phases, okay, from the new moon when the sun is hitting it, and we cannot see it actually in here when it forms, and then it's going to go through waxing crescent, quarter moon, waxing gibbous, and then full moon, and then it's going to go through the cycle again, okay? The moon goes around its axis almost 30 days, as much as it goes around the Earth. That's why it's always facing the Earth at the same time, because as it spins, it's rotating. So that's why we see only one face of it all the time. The Earth and the moon have a lot of effect. One of them is the tides, okay? And this is because, again, similar to what happened between the moon of Jupiter, Io, and because of this, there is these tidal forces that are always basically deforming the objects. And that is one effect. So the tides are 2 daily tides, twice a day, because of this motion, and they happen on this side, and they happen on the other side. The other side happened because of the inertia. On this side happened because of the force of gravity. Again, also one of the effects of the moon are the eclipses. You could have basically a full eclipse, or basically when the shadows basically form in this case. So you're going to, although the sun is much, much bigger than the moon, but it's very far away, that their size, their angular sizes are the same. So the moon, if it lands in front of the sun, it's going to block it during daytime. So this is a solar eclipse. And the other way around, actually, when the Earth is between them, that is when the lunar eclipse happens, okay? So this is a lunar eclipse, and this is a solar eclipse. And the only reason why the solar eclipse works is because although the sun is much, much bigger, if it were any closer, the moon cannot cover it. If it was any further, the moon would cover only part of it. It will not have a full solar eclipse. The only reason why they are is because of the fact that the ratio of the size to distance is the same. Sometimes you don't have full moons, full lunar eclipses, so you only have partial eclipse, and this is one of them. Asteroids, they're small rocky objects that exist mainly between Mars and Jupiter, okay? And they are basically left over from the early formation of the solar system, and they're different shapes, actually. They don't have spherical shapes because they're too small. The gravity is not too big to form them into spherical shapes. Okay, comets, they are actually mainly in the Kuiper belt and actually beyond in the Oort cloud, and they come in and they move around the sun. Some of the objects actually have left the sun a long time ago. Some of the objects, they are thrown out, and some of them are actually going through the circular paths in here. As I said before, they are icy when they are far away, around 5 AU, or they will actually start to heat up, warm up, and they form a tail. The tail is formed because of the solar, basically wind is hitting them, and the tail is forming in the back of them because as they're moving. And now they leave a lot of basically materials, debris. And when the Earth goes around this debris, is what we see them basically in the showers, the meteor showers that form from time to time, depending on our path in here. When we go around and cross this material, we're going to see those as meteor showers. And this is the pictures and how it looks like, depending on when we are in the time of the year. Okay. So this is in a nutshell the chapter. I know we almost consumed the entire time. And I'm hoping that you guys interact with the 2 questions of the day. Okay. So one of them is for February 18th, and the other one has to do with the planetarium. Well, enjoy yourselves. Please be safe. Do not gather more than, basically stick with what the law is saying to stay safe, and make sure that your family also is safe. And enjoy your holiday. And I will see you guys after Thanksgiving break.
Happy holidays.
Thank you. Let me stop the recording first.